They used to sneer at this vehicle, dismissing it as nothing more than a steel coffin. Critics insisted it could ignite like a matchbox, and that its crews were reckless daredevils doomed to perish inside a cramped metal trap. But if it truly were a useless pile of scrap, then why did elite NKVD units fight so insistently to obtain these machines for their most secret missions? What follows is a story of a very peculiar kind of technical cannibalism, where military engineers forced machines to return to service even after destruction, and why enemies who despised everything Soviet still guarded these captured vehicles like priceless treasures for nearly half a century. What you're about to learn about the BA-10 armored car will upend your ideas about war. Among the many experimental and sometimes fantastical prototypes of Soviet armor in the 1930s, its silhouette was impossible to confuse with anything else. One glance at the horizon of the pre-war era, and its distinctive profile immediately stands out. A long predatory nose, a confident stance on a 3-axle, 6-wheel chassis, and above all, a turret that looked like it had been lifted straight from a real tank. This was the BA-10, a machine that didn't trigger a thunderous technical revolution, didn't break the laws of physics or engineering, yet became something far greater, a symbol of maturity and confidence within the Soviet design school. It wasn't a mindless copy of Western models, as skeptics liked to claim, nor was it a worthless lump of metal that happened to end up on the battlefields of the Second World War. On the contrary, it was the result of a remarkably strict, consistent evolution. It represented the peak of an entire lineage of medium armored cars that had begun long before this machine appeared in steel. The BA-10 became the logical outcome of a technological chain, the embodiment of experience accumulated by Soviet engineers and the military over years, through mistakes, endless test-range trials, grueling marches across unforgiving terrain, and of course the first real clashes where theory faced the flames. The modernization of its predecessor, the BA-6, was pushed here to the absolute limit of what that era's technology allowed. The result was a vehicle far more prepared for war than many of its contemporaries. To truly understand its character, you have to look beneath its armored plates, into the place where design met the brutal road. At its core lay something familiar to any Soviet driver, the 3-axle GAZ-AAA truck chassis, heavily reworked and designated GAZ-07. At first glance, taking a truck and wrapping it in armor seems simple, but the devil hides in the details. The engineers knew that simply rearranging the components wouldn't be enough, so even the modest-looking alterations were crucial for the project's success. The frame was shortened, not to save metal, but to redistribute weight, lighten the load on the middle axle, and make the machine more compact. For a vehicle expected to operate not on paved highways, but on soaked dirt roads and real off-road conditions, every centimeter of wheelbase and every kilogram of weight mattered. It needed to move where others bogged down, and the shortened frame became the first step towards that goal. But armor and weapons are heavy, and that weight pressed hard on the front. A normal truck beam would never withstand such stress at speed over rough terrain. That's why the front axle was significantly reinforced. This compensated for the mass of the armored hull and turret, preventing the vehicle from nosing down on the first large rut or losing control at the worst possible moment. Yet one of the most elegant solutions was the use of hydraulic shock absorbers from the GAZ-M1 passenger car, the legendary MK. Imagine the difference between the bone-shaking jolt of a truck bed and the smoother ride of a sedan. Installing these shock absorbers fundamentally changed how the heavy armored car behaved on uneven ground. This wasn't done merely for crew comfort, though reducing fatigue on long marches was a welcome bonus. The main goal was stricter and more practical. Ride smoothness directly affected firing accuracy. The less the vehicle shook, the higher the chance of hitting a target from a brief stop or even on the move. By a curious twist, using components from a civilian car actually boosted the combat performance of this otherwise rugged military machine. The first prototype, incorporating all these improvements, rolled out of the factory gates in the summer of 1937, a period when industry was pushing its limits and adopting the latest production methods. Mass production under the designation BA-10A began in 1938. Yes, there was a brief pause, but it wasn't caused by design flaws. The manufacturing process at the Azura factory needed careful fine-tuning. The plant was already producing other complex machines, and introducing a new model inevitably required time. It was the maturity of industrial capacity that ensured the BA-10's success. It wasn't just the brilliance of its designers. The factory could consistently deliver quality not in single prototypes, but across an entire production series. When discussing an armored car, the first question is always about protection. The BA-10's armor thickness often invites criticism from armchair analysts who focus on raw numbers, 10 mm at the front, 6 to 10 mm on the sides and rear. At first glance, this seems thin, especially compared to tanks from later years of the war. But judging armor solely by thickness ignores historical context and the vehicle's actual purpose. It's 1938. The main threat to such a machine was not heavy anti-tank artillery or shaped charges. These barely existed. But ordinary infantry armed with rifles and machine guns, along with fragments from artillery explosions. 10 millimeters of quality rolled armor reliably stopped rifle rounds, even armor-piercing ones at combat distances of the time. This protection saved the crew and vital components from concentrated small arms fire, which Soviet armored cars routinely faced in pre-war conflicts. The BA-10 could confidently approach enemy positions without fear of being pierced by a burst from a handheld machine gun. Equally notable was the approach to constructing the hull. It was welded from armor plates, cutting-edge technology then, ensuring strength and structural integrity. Yet the engineers remained flexible. Elements difficult to weld or needing to be removable were attached with bulletproof rivets and bolts. This hybrid method combined the solid reliability of welds with the convenience of removable panels where necessary. If a panel needed to be removed for internal repairs, it could be done without cutting the hull. Equally crucial was how the entire steel shell attached to the chassis. Designers used a system of 6 main brackets. These weren't just mounting points, they were a carefully engineered force distribution system, providing rigidity and even load distribution while moving. When a multi-ton vehicle races over rough terrain, bouncing over bumps, the frame and hull endure enormous torsion and bending stresses. The BA-10's bracket system allowed it to survive long marches and sharp maneuvers without falling apart. The result was a solid, compact construction, ready for the harshest operational conditions. But armor is only a means to reach the fight. The BA-10's true steel fist, its real argument on the battlefield, was its armament. Here, Soviet designers refused to compromise. The turret housed a 45mm 20K gun, model 1938. For a wheeled vehicle of that era, this was truly formidable firepower. Its 46 caliber barrel gave the shell a high muzzle velocity, resulting in a flat trajectory and excellent armor penetration. Thanks to this gun, the BA-10 far exceeded the capabilities of a typical reconnaissance armored car, becoming a fully capable combat unit. The 45mm shell could strike not only infantry and fortifications, but also light enemy armored vehicles. The BA-10 could emerge victorious in a firefight against almost any opposing armored car and many light tanks of the period. Its 49-round ammunition load allowed sustained, intensive fire without fear of running out quickly. Complementing the main gun were 2 7.62mm DT-29 machine guns. One was mounted coaxially in the turret, the other in a ball mount in the front hull, next to the driver. Together, they produced a volume of fire comparable to light tanks like the T-26 or BT series. The BA-10 could mow down infantry, suppress strong points, and support advancing units with confidence. Special mention must be made of its aiming equipment. The PT-1 periscope and the TOP telescopic sight were standard for Soviet armored vehicles, but their presence on a wheeled car emphasized a serious approach to firing accuracy. This was not a fire vaguely in that direction weapon. The gunner could engage targets reliably at significant ranges. Of course, the BA-10 was not intended for reckless cavalry-style charges straight into fortified positions. For such tasks, its armor was too thin and its wheeled chassis too vulnerable. Yet it could enter real combat, operating stealthily from ambushes, supporting flanks, eliminating enemy armored cars at distance, and remaining a dangerous opponent throughout its service life. Even the most powerful gun, however, becomes useless if the vehicle gets stuck in the first muddy trap. Mobility was the Achilles heel of any wheeled design compared to tracked vehicles, but the BA-10's designers found a solution that was both simple and ingenious. One of its most unusual and recognizable features was the quick-fit track system, nicknamed the overall. This wasn't a decorative accessory. It was a true tool that turned a standard-wheeled armored car into a half-tracked all-terrain vehicle. The tracks fit directly over the rear drive wheels, linking them into a single tracked drive. In deep autumn mud, soft thawed ground, snowy fields, or swampy terrain, where ordinary tires would fail within a few meters, the overall allowed confident forward movement. The contact area increased multiple times, reducing ground pressure and preventing the vehicle from sinking. Most importantly, the tracks could be installed in just a few minutes. The crew could literally adapt the armored car to changing conditions on the go. This wasn't a maintenance task, it was a genuine combat capability. The engineers didn't stop there. Look at the BA-10's sides. Spare wheels were mounted above the main axles. At first glance, these seem like simple storage, but in fact they were on freely rotating axles. This wasn't decorative, it was a carefully designed feature for mobility. When the vehicle climbed a high mound, fallen tree, escarpment, or debris, risking a belly scrape, these rotating wheels were the first to contact the obstacle. They acted like rollers, helping the car literally roll over obstacles without catching its underside. This approach, where even auxiliary elements serve a functional purpose, exemplifies the ingenuity and practicality of Soviet engineers. Every component contributed to the result. Design thinking didn't stand still. Data from the first production series were carefully collected and analyzed, feeding back into refinements that made the BA-10 even more capable in the field. By the end of 1939, an updated variant appeared, the BA-10M. At first glance, the changes seemed purely cosmetic, but each was driven by harsh lessons from combat service and aimed at increasing crew survivability and the vehicle's own resilience. The most noticeable innovation was the relocation of the fuel tanks. In the early version, they were mounted on the roof, a risky choice to say the least. In the BA-10M, the tanks were moved into armored housings above the rear wheels. This solved two problems at once. First, it freed valuable space inside the fighting compartment and removed the fuel from the most vulnerable position, the top of the hull. Second, the armored housings offered added protection. Stray bullets or shell fragments were far less likely to trigger an instant fire that could destroy both vehicle and crew. Engineers also upgraded the turret rotation mechanism. The new system provided more precise aiming and, crucially, smooth rotation. In combat, when a target appears unexpectedly and moves rapidly, the ability to track it steadily is vital. Additionally, all tools and entrenching equipment previously mounted externally were moved inside or stored in locked compartments. This not only protected them from loss, but also cleared the hull's exterior, making the vehicle less cluttered and more streamlined. Remarkably, despite all the upgrades and an increase in weight to 5.5 tons, the vehicle's dynamics hardly changed. It retained the mobility and confidence of earlier versions in the same conditions. This demonstrated how precisely the designers had balanced protection, firepower, and mobility when designing the GAZ-AAA chassis. The reinforced front axle and sturdy frame provided a margin that allowed the armored car to evolve without losing its performance. The scale of BA-10 production is truly impressive and underscores its significance for the Red Army. From 1938 to 1941, factories produced over 3,392 armored cars of all variants. Of these, the first BA-10A version accounted for roughly 1,350 units, while the upgraded BA-10M numbered around 1,950. This made the BA-10 the most mass-produced Soviet medium armored car. Such production figures weren't just statistics. They reflected immense trust from the military in this machine and the ability of factories to deliver stable, large-scale output. Behind the dry reports lay the economic side of war. The price of a radio-equipped BA-10M was 56,046 rubles and 80 kopecks. A standard version cost 48,946 rubles and 80 kopecks. The difference of roughly 14% was substantial at the time. This covered the installation of a 71 TK1 or more advanced 71 TK3 Shakal radio set. The state's willingness to pay for communication equipment highlighted a shift in tactical thinking. Radio became the true nerve of the army. In 1940, of 987 vehicles produced at the Ajora factory, over 40% were fitted with radios, an exceptionally high proportion for an era when many tanks were still signaled using flags. The drive to create controllable, coordinated units capable of acting as a single organism became a clear priority. The antenna on the BA-10 turret was as vital a tool as its main gun. This design flexibility also allowed for rare, fascinating variants. One of the most unusual was the BA-10 ZHD, effectively a fully armored railcar built on the automotive chassis. The vehicle was equipped with interchangeable metal wheels with flanges, allowing it to travel on railway tracks while still being able to quickly return to normal wheeled operation. A total of 61 such vehicles were produced. 13 went to the Workers' and Peasants' Red Army, while the majority, up to 40, served within the NKVD forces. These unusual hybrids were deployed in armored train units, acting as light reconnaissance vehicles capable of moving rapidly along the rails, as well as guarding strategically important bridges, railway sections, and stretches of track. The BA-10's combat career began long before German forces crossed the Soviet border. The vehicle faced serious testing at Khalkhin Gol, in the Mongolian steppes, where it clashed with the Japanese army. Its durability and reliability were then proven in the harsh Soviet-Finnish War, where mobility and resistance to extreme cold were critical. The BA-10 also took part in operations to reunite the western territories of the country. Loss statistics are noteworthy. In these conflicts, 39, 10, and 20 vehicles were lost permanently, respectively, relatively small numbers for active combat. This speaks volumes about the vehicle's survivability and effectiveness when employed correctly. By June 1, 1941, the Red Army possessed 2,676 BA-10 armored cars of various modifications. They were distributed along the vast Soviet frontier, from the damp forests of the Baltics to the distant hills of the Far East. Tables from that era show how deeply the BA-10 was integrated into the armed forces. A tank division was supposed to have up to 56 of these vehicles, a motorized division 18, a motorcycle regiment 17. Even infantry and cavalry units, seemingly far from mechanization, received several BA-10s. This highlighted the vehicle's versatility. It was needed everywhere, from reconnaissance and communications to infantry and cavalry fire support. When the Great Patriotic War began, the BA-10s bore the brunt of the initial devastating blow. Serial production of these vehicles ceased in September 1941, as factories urgently shifted to tank production, which was far more critical in a total war scenario. Additionally, many industrial sites were either under threat of capture or in the process of evacuation. Yet this did not mark the end of the BA-10's story. The vehicles that survived the catastrophic summer of 1941 continued to fight. They were not scrapped. On the contrary, they were adapted to new realities. This type served especially long on the Leningrad front. In the besieged city, cut off from the main territory, every operational unit was literally gold. Repair crews performed miracles, restoring even heavily damaged armored cars. Thanks to their reliable construction and powerful armament, the BA-10s remained a formidable combat force both in positional battles and in operations attempting to break the blockade. They occasionally participated in combat up to the very end of the war. Even in August 1945, during the defeat of the Kwantung Army in the Far East, these old but proven armored cars returned to the battlefield, traversing the same steps where their combat careers had begun years earlier at Khalkhin Gol. Some vehicles experienced an extraordinary post-war fate. They were not immediately scrapped. In 1962, in Finland, where captured Soviet equipment was valued for its reliability, one BA-10 was given a second life. It was converted into a crane recovery vehicle, designated BA-10N. The turret and upper hull elements were removed and replaced with a rotating platform equipped with a lifting mechanism. This unusual hybrid of war and post-war service worked faithfully in the Finnish Tank Forces Technical Center until 1978. Just imagine, a vehicle born in the late 1930s for war, still in operation nearly to the doorstep of the 1980s Olympics. Isn't that the best proof that Soviet engineers built in an extraordinary margin of reliability, allowing it to remain relevant for decades? Today, when the roar of those battles has long faded, we can still see living steel witnesses of that era. At least 5 authentic BA-10s and 1 derivative vehicle have survived to the present day. Each is a unique monument. One restored armored car, brought back down to the last bolt, is displayed at the Museum of Domestic Military History in Podyakovo, gleaming with fresh paint as if it had just rolled off the production line. At the Parola Tank Museum in Finland, another example with its original tactical number, PS2712, stands silently, a witness to winter battles long past. But the most touching story belongs to a vehicle that returned from oblivion only a few years ago. In 2021, another BA-10 was raised from the bottom of the Mali Volkovets River near Veliki Novgorod. This armored car had belonged to the 28th Tank Division and was either deliberately scuttled by its crew or sank on its own during the fierce defensive battles of 1941. The water acted as a guardian. It preserved the hull from time, corrosion, and looters. The discovery and complex recovery operation became a major event for both historians and search teams. When the crane lifted the rusty, yet remarkably intact hull with its recognizable turret from the murky river, it was like touching the heroic past with one's own hands. This armored car ceased to be just a line in an archive or a dry mention in a history book. It returned to quietly but powerfully remind us of the courage of those who sat behind its controls and the talent of those who designed it. The BA-10 did not disappear. It remained at its final post, a perpetual guardian of memory.